Starting with Unity 6, the URP is now the default, and with many people having issues with VR performance, I'm going to guide you through the optimal settings for your VR project or mixed reality on the URP in Unity 6. If you're not interested in any of the details, the repository is down below, so you can copy this and try it out yourself. But in this video, I will go over every setting I changed to make sure you get the optimal performance. So we are going to make a universal 3D project and just call it URP VR demo. And let's create it and open it up. Alright, there we go. We got all our projects set up and we're going to remove the README assets because we don't really need those. So it should be set up with the new input system and URP installed. You can double check that in the package manager. If you go to in project, you can see all the assets that are here. For me, I am going to clean this up a bit because I don't need everything. For me, I don't need the AI navigation. You might do. I don't need JetBrains since I use Visual Studio. The timeline I might use. Multiplayer Center I don't need. I don't need visual scripting. I don't need version control since I use Git. And I think that's pretty much it. So we can simply remove all of these. And that kind of cleans up the editor and cleans up some performance. Next, we are going to the built-in settings. And here you can also disable whatever you do not need. Fun fact, if you remove the VR and the XR features right here, you will strip out all of those shaders in your shader build. So if you have any flat screen apps, definitely remove that to save some compilation time. But for example, right now we don't need any vehicles, we don't need video. Video might be nice for the Meta SDK, but no vehicles, no wind. Umbra is the occlusion system, we are not going to use that right now. We are not going to use any of the terrain systems, no tile maps, no screen capture, although it is a very nice feature. We definitely don't need any 3D. Yeah, what else is there? We don't need any cloth. And I think those are the biggest thing. Maybe no AI, but that's also, I think, used in some of the meta samples. But for now, let's just disable all of these. Terrain might be re-imported since it is used by the URP, but we'll see. Yeah, you see right here, terrain is still linked up. So that's used by the URP, but now the terrain physics stuff is not compiled, so might save a few seconds here and there, which does add up over time. Now for the project settings, we're going to go through everything we need to care about. For burst, this is very minor. We can optimize for performance, which might be nice. You can also check stuff like the health floating point and ARM v9. I think the Quest 3 has ARM v9, so that might have some extra optimizations. For now, we are not going to touch this, since it does add compilation time. But if you do a lot with burst, this might give back a little bit of performance. You can also do line only for the debug information, might help a little bit, just some small adjustments. For the editor, we are going to enable Sprite Atlas, and always enable this. And to get this working, we do need to have the 2D package installed, so that's the 2D Sprite package. And this way we can use the Sprite Atlases, which can actually improve performance quite a bit, to group together multiple textures into one texture. So that is very useful. To enable this or use it, you can create a 2D sprite atlas. And right here you can drag in all the objects for packing. I do recommend to disable these, and if you use alpha, to use the alpha dilation. But simply drag any sprites onto the object for package or any folders, and it will pack multiple textures into one. And especially for UI and stuff, this can be very nice to reduce draw calls. Other than that, I think all of these can be left at the default settings. For graphics, we can see that the PC render pipeline is set here. For us to have the baseline, the Quest 3 or Quest 2, we are going to use the mobile version. This is overridden by the quality settings, but we just want to have it play safe. Check that compatibility mode is disabled. This way it can use render graph, and render graph does help a lot for performance and memory optimization on the Quest. So definitely make sure this is disabled, and if there are any effects that break it, contact the developers of those, since you really want to have this set up properly. Next, these will be fairly important, are the player settings. Of course, make sure to set everything up properly. So definitely the URP VR demo. And here are actually some settings that do matter for performance. For the blitz type is something we are going to set to auto, since, well, if we don't need it, why do we need to blitz? So setting is to auto just picks it if it's needed, which might help a little bit. You can also disable the 32-bit buffer. This might have a very small performance impact. But hey, if it works and you don't see any decreases, that might be worth it. And if you have a very traditional 3D world, if you check disable depth and stencil, it will reduce the depth and stencil rendering. But this can break some effects, and I think mixed reality has a lot of issues with this. Don't quote me on this, but you can try to enable this, and if it works, that's great. If it doesn't work, make sure to disable this again, since depth and stencils are used relatively often. So just be aware of that and check this box and see if it works. For the splash screen, well, we can disable it, so for now, let's just disable this. And now there are a lot of settings here. We are going to remove OpenGLES, so it only uses Vulkan, since Vulkan is probably the way forward for VR, and all the new features are made for Vulkan. For GPU skinning, we are going to set as a GPU batched. If you have just a very few non-important skinned meshes, you could put this on CPU to clear up some GPU headroom, but usually GPU still performs better. So you can try out CPU if you're GPU bound. But quite often it's better to just put it at the GPU, since if the CPU does all this work, it might create more heat, also overheating the GPU, and in turn reducing performance. So put it at GPU batched unless you have any issues with GPU skinning. And if you do, maybe Animator LOD is nice. Next up, we are going to check graphics jobs, and we're going to do the split graphics jobs, which should be the most performant option. There have been some bugs with this in the past, so if you have some very weird graphics issues, you can try this disabled and enable it, of course, again, if it doesn't change anything. But this might have some better improvements. For the texture compression, ASTC is probably the best default option and should be default for most of your projects. I have heard that ETC and ETC2 is slightly faster, but with ASTC you can compress the textures a lot more, which should be faster than ETC2. So I suggest to put this at ASTC and just override the texture import settings manually. For the normal map encoding, let's put this to XYZ. This is a little bit lower quality, but should be faster. Of course, feel free to use DXT5. Maybe it works great for you. Just give it a go, and it might look a little bit better. Light map encoding, this depends how your game is set up. I personally use a lot with real-time lighting and set this to low, but this might be up to you. Don't check the HDR display output since the Quest doesn't support it. That's something which is quite handy to know. We're not going to use an override, that's personal preference. And make sure that you set the proper API level. I think we need Android 12L for the Quest. Again, don't quote me on that, check the documentation to get the latest requirements, but for us, let's just keep it at this. We do want IL2 CPP with the faster runtime and incremental garbage collection. That's the better option, and we want ARM64, so we can make use of the full 64-bit architecture. This all looks quite good and has been improved a lot since the recent versions. I am not sure why it says both on the active input handling. That is an issue since this can decrease performance and cause issues, especially on Android. So make sure to put this to new if it is at both and apply. I think some systems might even require this. So they require you to use the new input system like OpenXR. So interesting they got it as both for the default, but let's fix it for them. Alright, we are back in and we can see that the input handling is now at the new input system package, which is a lot better. Let's also double check if the package is actually installed. I think it was. Yeah, the input system is right here. That is great. Now to reduce the load times of people, we are going to pre-bake any collision meshes, and we are going to optimize mesh data. And if you use half texture resolution in the quality settings, you can check this box right here to remove some textures, which might be nice. I also see we are at Windows and we should be at Android. but these settings should go over. We can also change the striping level from the code. I suggest to keep this at low, but sometimes you can get away with medium or high. So give this a go, see if it compiles, and if so, that's great. You might save some space, maybe a little bit of performance, but this doesn't matter that much for performance. Next up, the important stuff, we are going to change the quality settings. For now, we are going to completely ditch the PC setup. If you want to have a more in-depth dive into PC VR, let me know and I can make a video for that. But right now we're focusing on the Quest. So right here, all of these can pretty much the default. I do always uncheck these. I currently don't use any terrains, but we definitely don't want any legacy stuff in here. This can be at the default. If you have issues with the LOD bias, you can change that here. And if you want to disable LOD crossfade, which does add a little bit of overhead, you can disable this right here. But crossfade does look better, so pick one or the other, it is really up to you. And for the skin weights, if you want really high definition animations for the hands, for example, put this at 4, and then for any models that don't need 4 skin weight bones, you can set this to 2 on the skin mesh itself. But for the hands, having it at 4 definitely is nice, so I do recommend to put it that way. Other than this, we don't need to use any of these. We are going to cover the XR plugin management settings in a little bit. So now let's remove the PC VR assets, since those are not used anymore, and dive into the URP settings, because these are very important. So right now the default is forward plus, which is very nice. This is in the mobile renderer. And here is the mobile render pipeline asset. And what forward plus allows us to do is use GPU resonant drawer. If you have a lot of objects, this can increase performance drastically. On the Quest, I don't recommend to use the GPU occlusion culling since it adds a lot of load onto the GPU, sadly. So this will be unchecked for our VR setup. But if you, again, have a lot of meshes that need to be rendered, GPU resonant drawer is a lot more performant. Quick note, if you want to use this, you need to set the batch render group variants to keep all. This, sadly there isn't a button, but you can go to the project settings, graphics, and here the batch group render variants should be at keep all. And you can see it is now disabled. It also says to decrease static batching, which is in the player settings, and here static batching can also be disabled. And this way you can fully utilize... Hey, why is it not set up properly? It also checks the PC version, of course. And this way it has the best performance. Note that using forward plus does add some overhead. If you have just one main light and that's it, and you want to dive into optimization, so you combine meshes and stuff so you don't have thousands of meshes, forward can actually be faster. So for simple projects, stick to forward, and if you have many additional lights, forward plus is always faster. And if you just use one light with a lot of small meshes, maybe forward plus with GPU resonant drawer can be worth it. But for us, we are going to stick to forward since this will be a simple project. For the depth texture mode, setting this to after transparency could be a lot faster. I am again not too sure why this is not the default. That's up to Unity to decide. But from testing from Unity themselves, they recommend after transparency for mobile devices. Sometimes force pre-pause is even faster. If you have a very complex 3D setup, you can try out force pre-pause, and for some people it got a performance improvement. Otherwise, just leave this at after transparency for now. On mixed reality, you want to check transparent receive shadows. If it is not required, if you have just a full VR game and it doesn't need transparent shadows, you can disable this, might save you some performance. For us to make this ready for mixed reality, we are going to check this. Disable the post-processing, this can all be stripped out since post-processing is very heavy to do. If you do want to use it, of course, keep this enabled. But for us, let's disable this. And the intermediate texture is already at auto, which is great. For the render features, these are all fairly heavy. Sometimes you use a render object or a full screen pass. But definitely for mobile, definitely don't use the screen space ambient occlusion. Even at the lowest settings, which is this one, and then depth, and then downsample after opaques, it is very heavy to do still, and you probably need application spacebar for that. So don't use screen space ambient occlusion and only use what's needed here. Maybe decals. Decals are very nice. So that's the URP renderer setup. And now let's go for the mobile render pipeline asset. You can see right here, the render path is not at forward plus, so we cannot use this, so we can disable this. We can also disable the terrain holes if you don't use terrain, because if you don't use a feature, let's just disable this. For HDR, the Quest doesn't have any HDR, disable this. We do want anti-aliasing to make the game look sharper. Start at 2x, but some games can definitely handle 4x, and it does improve the quality a lot, since it makes the meshes a lot sharper. For the upscaling, I suggest to do fidelity FX, since I don't think that's temporal. Otherwise, the spatial temporal post-processing also works great, but it might have some artifacting. Or you can just use bilinear or automatic and have it sort itself. For me, I am going to stick to what Unity recommends here, and hopefully that works. For the crossfade, I am going to disable this since I don't use that many LODs, but again, make sure to use what you need. For the main light, I would use this at per pixel since main lights do have a lot of improvements, and pick the resolution in what you need if you need shadows. Of course, baking lighting is better, but real-time shadows are fairly important. For mixed reality, 2K is usually actually recommended, or even 4K, since you do really see it if you're going up close. For the light probe system, use whatever you need. The default is the light probe groups, but the adaptive probe volumes are also great, so use whatever you need for your setup. For the additional lights, per pixel is a lot faster, so if you just want some lighting and don't mind a bit of a retro look, since this is a very old method, you can set this at per pixel. For us, we want to have a very realistic approach, of course, so we are going to put this at per pixel instead of per vertex. And you can change the per object limit here. So it is not too heavy to run the lights. But of course, the best way is to disable this and bake all of the lighting here, which is a lot more efficient. Also, disable any of the features you do not need. So if you don't need any of these, just disable them. Keep the shadow distance as low as possible. So if this can be, for example, 30, in mixed reality it can even be something like 15, since 15 meters away, if you're in a room, probably works. And you can increase the quality by increasing the cascade counts and changing these values. So stuff which is 2 meters away has resolution, and then the next cascade will be another 2 meters. This can be great to tune performance and balance out quality and performance. So pick whatever you need here, but of course less cascades, less distance, and less resolution is better. Same for soft shadows. This has a very high impact on mobile, so keep this at low if possible. High does look honestly very great, so if you need very good shadows, high might be interesting, but for performance, low is the best, or just disable it altogether. For the post-processing, let's degrade this as much as possible to 16. We want to use the fast system, and the data-driven and screen space lens flares do take up some memory, so if you don't need them, disable them. I think the other settings are pretty much done for. Here is still volume, and it also has stuff like bloom. Bloom is incredibly heavy, so if you want to use it, definitely disable this, downscale it, and limit the max iterations, since again it's very heavy to do. Or even better, disable this or yoink out the full post-processing in general. For lighting, bake this if possible, but sometimes it is not, and you just need to use real-time lights. If so, the default settings are probably fine. You do need to set the soft shadow quality to use settings from render pipeline assets. Another choice, I'm not too sure why this is not the default, since it should be, but sadly it is not, and we need to change it manually. For the main camera, right here, let's see if there are any settings we need to change. We can disable post-processing right here, which, again, if you do use it, keep it enabled. We are not going to use any occlusion culling for now. And I think the rest can be just at the default. You can also, which is nice for VR, which maybe the extra interaction toolkit does automatically, change the near field to at least 0.1 and the far field to how far you rolled is. If it's just 150, then definitely use that, so it only needs to render that far. So these are the quick improvements here. Now let's dive into the XR plugin management, since there are also fixes to be made there, since those are used most often, and I think the settings from both of them overlap a lot with other plugins. So for example, the Pico plugin has some similar settings to the Oculus one, since they have some very similar hardware. Let's start with Oculus. I suggest to leave this at the default for PC, and for Android make sure this is at multi-view. This is a lot faster than multipass. And basically check any of the settings I have right here. The overhead mode is nice if you run OpenGL. These are already enabled. If you use fixed foveated rendering, I do recommend to check this. This makes it faster and also improves the visual quality. So again, if you use fixed foveated rendering, enable this. Disable this if you don't, of course. Depth submission is fairly nice, so there's real depth between the game and the UI on the Quest. If you have the headroom, enable this. Disabling this might be a little bit faster. For us, let's enable this for now. Late latching almost always improves latency. I don't know why this isn't enabled by default. I never had any issues with it. So use this if possible, since it does feel better. And I'm not sure what the control stick is, since that's fairly new. But sometimes in the new input system, you can check this for some new stuff. I haven't used this, to be honest, so you can try to enable this. It might be nicer, might not. Enable all the headsets you want to use. So for us, that's all of them. And application space warp, I got a whole video on that, on how to set it up. You do need a custom URP package, so it's a bit more complex, but it can give a big boost in performance, and especially if you work a lot with static meshes, this can actually be a very real improvement for performance. But for now, it does degrade quality, so let's not enable this. Let's also quickly go over all the settings for OpenXR, not unimportant. Also select multi-view here or single pass instant as seen here. You don't need the additional render queue. Depth submission mode can be nice. That's, I think, the same as the depth submission right here. So you can even change this to 16 or 24-bit. 16-bit is faster, or just disable this. For the foveated rendering API, use the SRP foveation if possible. Now quickly go through these settings. I'm not sure if you can do anything here. Now, if you want to change performance settings on the, I think the Quest mainly, you can do that with the XR performance settings. And let's dive into the Quest settings here. We do want symmetric projection since it's faster, optimize buffer D cards, support all the headsets, maybe not the Quest 1 since it's not even supported anymore. And late latching here is in experimental, but we are going to be on the edge and use it. So enable that, and that should be set up as we need. And for the rest, this is very much project specific. If you want some deeper dives in how to import textures and go over all the settings there, definitely let me know. I know this video has been going on for a while, so if you're still watching, thank you very much, and I hope it helped you. Again, let me know what you thought of it. If you have any questions, let me know in the comments below. I would love to help out and give some pointers where needed. Thanks again for watching, and I hope to see you in another performance video.